Hi everyone, Quiveen here from the comfort of my kitchen. In today's video, we won't be looking too far ahead, just into the coming week, to take a closer look at the planet Mercury. We will look at Mercury at its greatest elongation later this month into next week, but we are going to concentrate more on Mercury more generally, how it appears in close-up and how it moves around the sun. As we push through, just so you know, Saturn and Jupiter are still there as we push through January. We look much further into the coming year in previous videos, and they will eventually disappear from the sky for a period of the year, but they're still there for now. We're pushing all the way through to morning time because, of course, that's where we need to be to see Mercury at its greatest western elongation. When Mercury is west of the sun, we see it in the east. If you've watched a few of my videos, you've heard that several times now, but it's counterintuitive enough that I like to repeat it. So here we go. There's Venus, there's Mercury. That's how they're going to look in the morning. It's around the 12th or 11th that Mercury will reach its greatest elongation. Mercury, as I mentioned in the past, its year is 88 days long, 88 Earth days. Of course, a day on Mercury is a very different thing, but because Mercury and the Earth are both moving, Mercury will appear to come back around to the same place about every 116 days or so. Mercury has a highly elliptical orbit. It has the most eccentric orbit of the planets. So it is going around the sun in very much an ellipse rather than a circle. And this means that because it's got such an elliptical orbit, as that ellipse proceeds around the sun, we're going to see Mercury at aphelion and perihelion, it's closest to the sun and it's shortest to the sun as Mercury moves around the sun and as we do. So Mercury and the Earth, we do see it reasonably regularly, but we're not going to see its greatest elongation on the exact same date every year. We will usually see a greatest elongation of Mercury reasonably regularly. We're normally going to see a greatest western elongation sometime in January, possibly February, but it does vary from year to year. But here we are looking at Mercury. It has this lovely grey surface, and because I've gotten rid of the atmosphere, I'm going to get rid of the ground here as well. We will be able to take a look at a full Mercury. This isn't something that's actually possible to the Earth. Once we're looking at it, great, so that's pretty much a full Mercury. Even as we come around a little bit further, that's Mercury coming around the other side of the sun and starting to come back to its greatest eastern elongation, which we're going to get at around March. But we can see here that Mercury is covered in these features. It has all of these craters and light spots and lines. Mercury, just like the moon, it doesn't really have an atmosphere. What Mercury has is an exosphere. So at the very edge of the Earth's atmosphere, we have an exosphere as well. It's where there are molecules of gas that are bound to the planet by its gravity, but there's so few molecules of gas, they're not really bumping into each other. Sound can't really propagate. Heat doesn't travel the same way. Heat gets through space mostly through radiation. It doesn't really convect or conduct through the vacuum. Mercury and the moon really only have exospheres. They don't have any denser collection of gas because, well, smaller objects don't really have the gravity to trap that much gas. So something like Mercury is only going to have a very thin packet of gas around it, and that is the exosphere. So Mercury, it is a very interesting planet. If you can take a look at it, it is very, very hard to take a look at. Because Mercury is so close to the sun, even a lot of very powerful space telescopes like the Hubble Space Telescope, they can't safely look at Mercury, and safety is the important thing here. You can technically observe Mercury during the day when it's at its greatest elongation. If you have incredibly good safety equipment, if you've got a particular type of telescope or a very protected telescope, you can do it, but it's generally not considered safe. The same way that you can see Mercury with the naked eye during a total solar eclipse, but you shouldn't be looking anywhere near the sun with your naked eye during a total solar eclipse. You need some kind of protection. It's easiest and safest for us to observe Mercury with our eyes during the day. Of course, we can send things to Mercury, and this is one of the ways that we study planets that are difficult to see with our eyes, or study anything that's difficult to see with our eyes. We use telescopes if they're far away and microscopes if they're really small. We need a little bit of help. With Mercury, it's very, very hard to land anything on it. Mercury is quite a small planet, so its gravity is not particularly strong. Because of this, if you're shooting a little probe towards the biggest, most massive thing in our solar system, the sun, and hoping that it lands on this tiny little ball of rock, well, your calculations better be pretty good. It's difficult to hit this small target because it's next to such a big target, and the gravity well of the sun will almost take over. While we're looking at this map of Mercury here, I do want to find something in particular that's around 30, 60 north and east. So I think I need to go a little bit lower here. Yep, down around the 30s, 68. There we go. Around the 30s and the 60s. So there is a white patch in there. I'm not sure if this is the white patch. It may be a crater. Some of the white patches on Mercury are just paler areas that may be evidence of old volcanism. Mercury doesn't have much of a liquid mantle anymore. It has a giant iron core, so it does have a magnetic field, but there's no liquid stuff moving around. So its magnetic field is quite weak. These white areas are known as faculae, and they're named after snakes. Now, we don't have that many personal names for snakes, so it's the word for snake in different languages. This faculae is called nahar, like nahar niva, the Irish for snake. Nahar niva being a poisonous snake. They're normally the ones we talk about, but that is the nahar faculae. If you speak a language that isn't English, there's a good chance that there's a faculae up there named in your language. Of course, there are plenty of other features like craters and valleys and little ridges that are named after other things like observatories and astronomers. There is one down there named Chekhov as well, I believe after the author, potentially after an astronomer with the same name. But we're going to go right down onto the equator of Mercury. Now, I am only guessing here, but Mercury orbits the sun in a particularly strange way. So let's move through some days here. A day on Mercury is incredibly long. As Mercury orbits the sun, it resonates with the sun. So there is a There we go, we are moving. There is a resonance between Mercury and the sun. So for every Mercurian year, for every 2 years, we get a Mercurian day. So the day on Mercury lasts an incredibly long time. A day on Mercury lasts longer than its year because Mercury is turning around so slowly. There we go. That's the thing I was hoping to catch. So because Mercury is orbiting around the sun in such a slow way, and because it's turning in such a particular way, it will face the sun for a lot longer. Mercury isn't tidally locked. It doesn't keep one face to the sun all year long, as the moon does with the Earth. The same part of the moon always faces the Earth. There are other moons that are tidally locked facing their planet, and we do believe that there are planets that are tidally locked, stuck facing the sun with the same face all of the time. And we believed that Mercury did that, but it's not the case. Mercury is rotating. It's just doing so in a particular resonance with the sun, a 3-2 resonance. So we can see here that the stars appear to be moving behind the sun much quicker than the sun is moving across the sky. And just around here, it appears to rest quite a while. It even appears to travel backwards and then forwards again. There we go. That's that retrograde motion of the sun. And this is only happening on Mercury because of the fact that it orbits with such a resonance. It stays facing the sun for a lot longer in its year than it would do for a day. Of course, the sun does eventually set on Mercury, and we can see it should be slowly starting to set now. It still appears to be moving backwards compared to the stars, but overall it is moving to Mercury's west. And Mercury is spinning the same way as the Earth. The sun will appear to move from east to west, as will everything else. That's not universal with the planets. Planets can rotate the other way. There goes the sun setting. So that was a day on Mercury, but it was longer than a Mercurian year. So Mercury has come the whole way around the sun in the space of what took the sun to pretty much rise and set. So as Mercury goes around the sun, it has this particular resonance. And we only see this strange effect from certain areas. You do have to be right on the equator, at certain parts of the equator, to see this resonance happen. So I am quite lucky that I guessed the right location. I could have been wrong. So that's what the sky looks like from Mercury. Of course, Mercury only has an exosphere, so oh, well, Stellarium's giving it a proper atmosphere. You need a lot of oxygen and nitrogen to get this lovely blue scattering in your atmosphere. Mercury doesn't have that. This is pretty much what you would actually see from the surface of Mercury if you were looking out into space. So the smallest planet in our solar system, the closest planet to the sun, it has a couple of other strange things going on, such as this resonance and the strange length of its day compared to its year. Because of Mercury's strange orbit around the sun, it is, well, really, compared to other potential orbits that it could have, it could be orbiting retrograde. It could actually be moving backwards, and it's not. But it does have a particularly strange couple of orbital phenomenon compared to the other planets. We don't see that weird motion of the sun from other planets because they're not in resonant orbits with the sun. Now, we've moved way, way forward. We've moved months into the future, so let's travel right back here, back to January, and there's Venus and Mercury. And they look a little bit strange because I am on the same place on Earth as I was on Mercury. And that means I'm very close to the equator. And that is how this would look if you are very close to the equator. You can see that the planets are almost forming a straight line above the horizon. And that's because we're closer to the equator with this view. In fact, this is almost south of the equator. You do get a slightly better view of Mercury from these areas south of the equator, down around Argentina and South Africa. If we zip ourselves back to Ireland here and bring ourselves back out to daytime, you can see that angle is much, much shallower, making Mars much, much harder to see. It will get back into our sky eventually, but for now, that's Mercury, smallest planet in our solar system. I hope you found the planet interesting. There's loads more to say. We'll get back to Mercury in the future, look more at its orbit from a different perspective. But until then, I hope that you like this video and subscribe to the YouTube channel so that you get to see more of these videos and I get to keep making them. And if you'd like to check out a little write-up about this video, you can go to queevinscontent.ie, where I write a little bit about these videos if you'd rather read some of it. So I hope you'll join me back again next time.